Alrighty, welcome back ladies and gentlemen, boys and girls, cats and kittens. We're going to be talking about section 2.7. This is polynomial and rational inequalities, and we're going to solve these things by hand. Alright, now when we're solving these polynomial inequalities, we'll start with those first. Okay, one of the things we're going to want to do is get a 0 on one side of the inequality in general. There will be some exceptions to this rule, and I'll demonstrate one of those. Then we're going to want to find critical values, which are simply the zeros of the polynomial. So that's kind of one of the reasons we want to get a 0 on one side. Alright, then we're going to test x values between those critical values. Basically, we're going to test whether or not it's basically true or false in that interval on the number line. And then from there, we'll graph our solution on a number line, write it using interval notation, all that kind of fun stuff. Alright, so let's get going. Okay, so let's take a look at our first example. I got x to the third plus x squared greater than 12x. Okay, well again, first thing on our list of things to do was to get a 0 on one side. So by taking the 12x to the other side, we have x to the third plus x squared minus 12x. Now that's going to be greater than 0. Okay, now from there, generally we want the 0 because most of the ways of solving polynomial equations have a 0 on one side. So that's why I'm going to say in general, but not always. Okay, so here we can factor out an x, and that gives us an x squared plus x minus 12. And hopefully from there, you don't have too much issue getting this thing factored, so we're going to need a plus 4 and a minus 3 to pull off that factoring, greater than 0. Okay, and so now what we've been able to do from here is basically what that step 2 is, and it's identify the critical values. Okay, critical values are such where the polynomial expression actually changes from positive to negative at that particular value, or vice versa, again with the 0. Alright, so basically what I'm looking at now is if I slap down a number line here and then take a look at the critical values in the number line, of course I've got 0 from just the x by itself. The x plus 4 gives me a 0 of negative 4, and then the x minus 3 gives me a 0 of positive 3. Okay, I don't care if you do this to scale or anything like that, but of course I do want them in order. Okay, and at this point now we're going to test various regions of the number line and see whether or not it makes sense. So we're going to pick values wherever. You don't actually have to write these out, but just for notes purposes I'm going to do this. Like maybe I'm going to pick negative 5, because that's on the far left end, and then somewhere between 0 and negative 4, maybe I'll just pick negative 2. Same thing between 0 and 3, let's just pick 1, and then 3 to infinity effectively. Maybe I'll pick something like 7. Okay, so these are going to be my test values that I'll test in each region. Alright, so first things first, let's test the negative 5. Okay, now you can plug it into either the original or technically any version of the equation as you kind of manipulate it around. I honestly like to plug it into the full factored version, at least most of them. There's one exception, but we'll get to that later. Okay, so the negative 5, and I'm comparing it to 0, so I don't even care if it's, well, the number, I just care if it's positive or negative. So basically, as I plug in the negative 5, I get a negative first. Okay, I plug in negative 5 plus 4, and that's also a negative value, and then I take negative 5 minus 3, that's also negative. So 3 negatives make a negative, and I want to be greater than 0, and 3 negatives makes me not greater than 0, so the negative 5 region of the number line is kind of sad, because he doesn't work. Okay, by plugging in something negative 2-ish, okay, negative 2, it's going to give me a negative to start with, but then this guy gives me positive, and then by plugging in the negative 2 over here, it's going to give me a negative. So I get a total of 2 negatives and 1 positive, so that's going to give me an ultimate positive result, so that means that part of the number line works. So woohoo! Alright, plugging in the 1, okay, maybe you'll notice a pattern here, but the 1 I get a positive for the first part for just the x, and I get a positive here, but then I get a negative there. So positive, negative. Okay, so ultimately I do have a negative response, and again, since I want to be greater than 0, negative is something that I don't want, so I'm very, very sad about that. And then you might hopefully put this together pretty quickly as I plug in the 7. Okay, positive, positive, and positive. So the 7 gives me 3 positive. And of course, if I multiply 3 positives, I get a positive result, which is what I'm looking for in this particular problem. So woohoo! Excited again. Okay, so then now using our proper interval notation sort of method for doing our number line. Alright, again, greater than indicates that I'm going to be using parentheses instead of brackets. Okay, so I'm going to parenthesis the negative 4 to 0 region of the graph and shade that in, showing that this is part of my solution. But also again over here to the right of 3, and starting at 3 and going to the right. I like this part of the graph as well. Okay, so there's the graph, which I think is kind of nicer to do. And these things than writing the interval notation, because the interval notation lends itself so nicely to coming off of a number line. So as far as my interval notation goes, I've got parentheses -4, 0, and then I've got a union because I am putting two different pieces together, and I'm going from 3 all the way up to infinity. Okay, so there'd be both the number line and the interval notation versions of those, depending on what's being asked for at any given time. Okay, now let's take a look at one that's going to play out a little bit differently, at least depending on the slant you take on it. Okay, option number 1 basically is to handle it very much like with the last one, where we could take this x plus 8 quantity squared and we could FOIL it out and then subtract the 12 from both sides, and then we'd have something that looks very similar to the last one we did. But to avoid redundancy here, what I'm going to do is handle this in a different way. Okay, now remember, I said in general we want a 0 on one side, but sometimes the equation's set up in such a way that, it might be nicer to handle it another way, and I think at least this is one of those times. Okay, so what I would do here is, because what I'm looking for is the critical points. So what I'm looking for is the points where x plus 8 squared is equal to 12. Alright, so realistically I don't really care about the inequality sign, at least for finding the critical values. However, when I'm doing my comparisons later, I'm not going to be able to use what I do over here because I need this greater than sign, and I'm about to kind of mess that up. Okay, so by square rooting both sides here, just again to find the critical values, I'll get x plus 8 equals, okay, I have square rooting, so I need a plus or minus, and then the root 12, of course, simplifies into 2 root 3. Please don't forget to do that. Okay, now at this point I can subtract 8 from both sides and get my critical points being -8 plus or minus 2 root 3. Alright, and so now I'm going to put those two on the number line. Yes, that's what we're going to do. So slapping down a number line. Okay, again, I do have two different values here, so I'll just put 2 tick marks. Okay, well, I've got -8 minus this root, so I think that's definitely going to go on the left because that's going to be definitely smaller, and then -8 plus that root is going to end up being bigger. So 2 root 3. Okay, now one thing you're going to have to be able to do in this is kind of recognize that root 12 is approximately 3 point something. It's kind of 3.5-ish, but I think that's something you can come up even without a calculator, because of course if I had root 9, that'd be dead on 3, and if I had root 16, that'd be dead on 4. So root 12 has got to be somewhere pretty much in the middle of that. Okay, so as a rough estimate of both of these roots, it's about a 3.5. So the -8 minus 3.5 is kind of -11.5-ish. Okay, now I don't want you to use that as part of your answer, but when we're picking values in each region of the number line, it's going to be kind of important to know about what that is. Okay, same thing over here. If I've got -8 plus 3.5-ish, okay, that's going to give me something along the lines of -4.5. So again, very important to know as I pick values. Okay, so let's do that. Again, now that I know this is a -11.5 here, I need to pick something that's definitely less than that. And again, just to avoid any sort of round-offy sort of craziness I might have done, I don't want to pick -12 because that might be cutting it too close, so I'll pick something like -13. Okay, or I could have gone further down, but whatever. Okay, then again, between -11.5 and -4.5 is going to give us this region here, and again, I don't want to pick too close to the edge, so something about -7-ish sounds pretty good to me. Actually, a -8 would have been a nice one, but hey, let's move on. Okay, and then here's still a negative number, so whenever possible, I'm going to pick 0. 0 is a great one because it just cancels out a bunch of x's and usually works out to be an easy thing to work with. Okay, so anyway, testing what we have. Again, over here, because I square rooted both sides, I kind of killed off any usefulness of an inequality sign without getting crazy. So basically the drawback of handling it the way I did is I have to test this back in the original. Okay, so plug in the -13 here. I've got -13 plus 8, and of course that gives us a -5. Okay, but I'm going to square that and then compare it to 12. Well, that's 25, of course, and 25 certainly isn't less than or equal to 12, so okay, not very happy right there. Okay, testing the -7. -7 plus 8 is going to give me a +1 squared, less than or equal to 12. Well, that sure is. Okay, and then plugging in the 0 again. 0 is really nice because that just kills itself right there. And we're left with an 8. So 8 squared, I'm pretty sure that's 64, and I want to make sure that's less than or equal to 12, and alas, poor Yorick, it is not. Okay, so as far as our number line goes, and again, now we have the or equal to, so we'd have brackets around our good region, if you will, which in this case there's only one of them, so we'd end up with a number line looking vaguely like that. So again, as far as our final answer number line goes, I really just want to carve out this part of the number line. Okay, and then I didn't really leave myself room in there for the interval notation version of the answer, but it would look like -8 minus 2 root 3. Sorry, that 8's leaning over a little bit. And then -8 plus 2 root 3. Again, that probably doesn't mean much to most people, so that's why, again, I think it's a good idea to kind of have a rough idea of what those decimals would be. So, about 11.5 to -4.5 is our good region. And that's how it shows up in the interval notation. Okay, please keep in mind anytime you need to use something like the quadratic formula or something like that in this, I'm not a big fan of rounded answers, so you will have answers that look like this sort of thing, the -8 plus 2 root 3 kind of deal. So just expect it. It will happen. Please don't give me decimals for that, because it will make me sad and hurt my feelings and destroy my self-esteem, so please don't. Okay, let's talk about rational inequalities now, and basically the steps are almost identical to what we just had for the polynomials. A couple little differences I want to point out, which is why I've listed them again. But first of all, we need to get a 0 on one side, and this is going to be an always sort of situation. The other one, there were some kind of issues you could work around, and it wasn't such a big deal, but this is really going to be an always scenario. Then we're going to have to find critical values again, but in this case, it's just the zeros in the numerator and the denominator as well. Okay, so, and another little thing, if we think about how denominators work and how zeros of denominators would work, they give you undefined values. So the zeros of the denominator cannot be part of the solution. So regardless of the inequality sign in the original problem, we're always going to use parentheses when giving the answer for those denominator values. Okay, so keep that in mind as we do this. And then basically we're going to test x values again and then write and graph our solution. Okay, so let's take a look at one of these guys in action. Okay, going with the crawl before you walk sort of scenario here. I've got this rational sort of expression, and it's one big fraction, okay, which is kind of nice because I don't have to worry about trying to add or subtract or anything like that to condense it into a fraction because it's already there. Hint, if you don't already have one, you're going to need to do that. Okay, so right away, I'm taking a look at this guy and thinking, okay, how can I get this guy factored? Because that'll probably do me some good, especially for finding our critical values. So since I got my 0, I can move on to that. Okay, so factoring the 24 into a 3 and an 8 will give me the 5 in the middle. Alright, and sign-wise I need a +8 and a -3. Okay, and then of course the x squared minus 16 gives me a very quick and simple x plus 4x minus 4. And again, I'm concerned about this thing being greater than or equal to 0. Okay, so basically I have 4 critical values. Okay, I've got +3, I've got -8, and I've got -4 and +4. So I'm going to have a pretty busy number line here, so I'll make it kind of big. Alright, and again, putting these guys numerically is very important. I'll have the -8 is my smallest one. Okay, then I've got a -4. Okay, again, I don't need to scale, but I do need in order. Alright, and then I'm going to get a +3 and a +4. So +3, just to kind of go to scale, I'll put them semi-close together, but again, I'm not going to get too worried about it. Okay, so again, I need to pick 5 different values here because I have 5 pieces of my number line, if you will. Okay, so again, for the -8, I just need to pick something left of there. So maybe -10, or if you're so inclined, pick -3,422. Okay, between -8 and -4, well, -6 sounds fun. Dead center, sounds good. Again, here's where my 0 lives, so I'm going to pick him every time. Between 3 and 4, I've got a little bit of a challenge ahead of me because I have to go with some kind of a decimal, so I'll pick 3.5. And then again, from 4, well, maybe I'll pick 672. Alright. So these are my values that I'm going to pick and test in here to see if it works. Okay, and again, all I'm comparing is to 0, so all I really need to know is positive or negative. So as I plug in the -10, I'll give myself a little ghost fraction bar there sort of thing. As I plug in the -10, I'm going to get a negative on the upper left, I'll get a negative on the upper right, and a couple of negatives down on the bottom. And maybe that looks better in parentheses, but you get the idea hopefully. Okay, but 4 negatives makes a positive, and I do, in this case, want this guy to be greater than 0, so positive is what I want, so I'm happy right here. So I can squeeze in a smiley face. Yay! Okay, -6. Well, as I start plugging things in, I get a negative upper left, I get a positive upper right, and then I get a pair of negatives on the bottom. Okay, so ultimately that's a negative answer, and I want to be greater than 0, so he's very, very sad. Okay, plugging in the 0. Again, very simply comes together, at least I hope it does. I get a negative there, I get a positive there, and I get a positive there, and a negative there. Okay, so 2 positive, 2 negatives gives me a positive result overall, so I'm just ecstatic right there. Okay, 3.5, again, it's a little messier, but again, all I really care about is positive or negative. So as I start looking at what I got, 3.5 minus 3 does give me a positive 1/2, but again, I don't care, I just care about positive. I'm going to get a positive right there with the plus 8. I definitely get a positive there by adding 4. And I do get a negative there because 3.5 minus 4 does send me to a negative 1/2, but again, I don't care about the number, I just care about positives. And right here I'd get an overall negative response, so I'm again just crushed emotionally. Okay, then when I plug in my 672, again I kind of took a ludicrous answer right there, or ludicrous number, just again to show that, hey, I'm plugging this in and I'll get positive, 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 positive by plugging in that gigantic number. Very much in the same way that I got negatives for every factor when I plugged in a very large negative number. Okay, so anyway, since he's going to come out completely positive, again, I'm just jumping for joy. Alright, so now here's where we've got to be a little bit tricky about things. Okay, the 3 and the negative 8 came from the numerator, so we can include those in our answer. Okay, so as I deal with the negative 8, I want to use my bracket because I had the or equal to bar, so I'm going to include him, and he's going to take off to the left. And then again, the positive 3 is somebody I'm going to include. So again, here's the happy face. So to the positive 3's left is some good stuff. So again, I'll kind of give myself a nice bracket here with that. Okay, the positive and negative 4, they came from the denominator. And of course, if I have a negative 4 plugged in here, it's going to give me a 0 denominator and I get something undefined. So again, like I said in the rules, I can't include the actual value of negative 4. So I do need to actually use a parenthesis on that negative 4 as I close off this good interval between these two guys here. Okay, likewise, this positive 4 comes from this guy, part of the denominator. So as I indicate my interval that I like, I need to use a parenthesis there because I can't include the positive 4 itself. Just go past it. Okay, so notice we have a 3 interval number line here, and we can do that with interval notation just fine. Okay, so I've got negative infinity up to negative 8, and then I got to throw down a union symbol, parentheses. Ooh, I messed up. Okay, I need a bracket on that 8. Okay, don't tell anybody I messed up. Let's keep it a secret between you and me. Deal? Cool. Alright, so we get the negative 4 up to 3, and then again I need a bracket right there. And again, now I have a separate region, so I need to put down yet another union symbol, and then parentheses because I'm not including the 4, and then going all the way to infinity. Alright, so there's both the number line and the interval notation version of that all together into one big happy family. Alright, now taking a look at this one. Okay, this one's got 2 problems right off the bat that the last one didn't. First of all, is I don't have a 0 on one side or the other, and the second thing is that I've got not a single fraction. So I'm going to have to get everything on one side, and then I'm going to have to condense everything into a single fraction before I can start doing everything I did on that last problem. Okay, so here we go. I have a choice. I can smash everything to the left or to the right, and it doesn't really matter, so I'm just going to go left with this. Alright, so 3x over x minus 1. Okay, now I'm going to have to subtract the x over x plus 4. And just because I know I'm going to have to squeeze in some common denominator sort of expressions, I'm going to leave a little bit of a gap before I put that minus 3 on there. And again, I'm going to have some common denominator stuff going on, so I'm going to leave a big gap there as well before I put my less than or equal to 0. Okay, now again, for common denominators, I'm going to have to worry about keeping up with the Joneses. Okay, so this guy looks across and sees that x plus 4, so he needs a top and bottom. Okay, this guy sees that x minus 1. Alright, now he's happy, and unfortunately there's 3, since he's sitting on top of a 1, well, he needs them both. So he gets an x plus 4 and an x minus 1. Okay, one other thing you might want to do on this, and let's see if I can pick a nice pretty color, is again, since you're subtracting a fraction, one thing that helps people from making sign mistakes is change that to a plus, and then that's a negative. Same thing you might want to do for the 3, although I think it's a little more obvious here, so I'm not going to worry about doing that. Okay, so now we have a whole lot of multiplication to sort out. Okay, the 3x distributes into the x plus 4, so I've got myself a 3x squared plus 12x. Okay, now the negative x distributes here and gives me a negative x, and then a positive, negative x squared, and then a positive x, and then here's kind of the nasty one. So just to save a little time here, I'm going to FOIL this out, x squared, that'll give me a plus 3x minus 4, and now I'm going to distribute a negative 3 through it, so I get myself a negative 3x squared, and then a minus 9x, and then a plus 12. Okay, and that whole mess of stuff is sitting on top of our common denominator of x plus 4, x minus 1. Okay, again, less than or equal to 0. Okay, now right now I know I'm going to have values of -4 and 1 as critical values, but I do have a whole thing on the top to work out first. So here we go. Now conveniently, I've got a 3x squared and a -3x squared, so those guys go bye-bye, which is nice. And then I've got a whole other stuff, bunch of other stuff that doesn't quite get along as well. So -x squared, got a 12x and a -9x and a positive 1x, so it's really 13 minus 9, so that's 4x. And then as far as constant terms, I've just got the plus 12, so there we go. Okay, again, I've got my x plus 4x minus 1. Okay, now hopefully what you're thinking as I write the rest of this out is that, hey, I got a negative sign right there and I don't really like it. So we have a couple options. We can multiply both sides by a negative, and that would reverse this inequality sign here. I generally don't honestly like to do that. What I would typically tend to do here is actually just factor out the -1. And so by doing that, I get myself an x squared minus 4x minus 12, and that's living all on top of, again, the x plus 4 and the x minus 1, still setting the less than or equal to 0, and then from there, again, I've got a little more factoring to do. Okay, factor my numerator. Okay, I'm going to have an x plus 2 and an x minus 6, and then I give it that other stuff, x plus 4, x minus 1. Okay, and at this point again, now I'm looking at my critical values, and just keep in mind as I'm testing things, I've got this -1 I'm going to have to contend with, so I basically have an extra negative built in for all of the tests that I'm going to do. Okay, so space concerns, I'm going to have to kind of cheat a little bit and just kind of work my way to the right. Alright, and again I've got 4 zeros, and just working my way from low to high again, I've got a -4 as my smallest critical value. I've got myself also a -2, then I got myself a 1, and then I've got myself a 6. Okay, again, plugging in various values, again I'll test something like -5. Shields off. Okay, not much choice but to test -3 unless you want to test fraction of decimals. Again, there's where 0 lives, so I'm going to use him. Between 1 and 6, and maybe let's use 4, and then beyond 6, and maybe 13, sure. Okay, and so now again, plugging these guys back into this mess to see what works and what doesn't. Okay, the -5, okay, I've got a negative there, of course, and then I've got another negative, 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 negative. So basically I've got 5 negatives, which gives me a negative result, and I want to be less than 0 in this case, so actually with the -5, I'm thrilled. Okay, the -3, you might have noticed the pattern and be able to predict what's about to happen here, but as I plug in the -3, I have a negative, 2 negatives, 3 negatives, a positive, and then 4 negatives total. So 4 negatives gives me a positive, but I want to be less than 0 in this case, so by being positive, I'm very sad. Okay, the 0, okay, so again, negative, positive, negative, positive, negative. So I had a total of 3 negatives, so negative answer in this case makes me happy. Hopefully you can kind of guess this by now, but as I plug in the 4, I'm going to get a positive result, and that makes me sad. Plugging in a 13 gives me a negative result, and I'm thrilled. Okay, so again, going back to what the graph is going to look like. Okay, -4 came from the denominator, so I'm not allowed to keep him. Alright, so I use a parenthesis there, and this guy goes off to the left. Okay, don't want it there. -2 came from the numerator, so he's cool, I get to keep him. Alright, and then the 1 came from the denominator, so I don't get to keep him, but I do get to keep all the numbers in between -2 and 1. And then likewise the 6 came from the numerator, so he's a happy number, and from there I get to go off to the right all the way to positive infinity. Okay, so again, there's my number line, which again quickly translates into negative infinity up to -4, parentheses, union, bracket, -2, comma, 1, parenthesis, and then union, bracket on the 6, going all the way to infinity. So there's again your graph and interval notation answer. And sorry it's a little sloppy over there, but hopefully you get the idea.